The world is constantly changing and will continue to change. Actually, we'll already understand this phenomenon, but unfortunately, our perception is often distorted. We always think it will happen in the future, and without us knowing it, we are now in the future with all the complex problems, the future with the effort to find the best solution, the future are right now. The era of globalization has really become a wake-up call throughout the world, proving the system is not ready for change, and one of them is in overcoming energy problems through join the transition. As least on the Paris Agreement on 2015, all countries must reduce their carbon emission, which is that the energy sector of the earth temperature threshold below 2 degrees Celsius, and we need to reduce it to 1.5 degrees Celsius above the earth temperature. And moving on, we know that the potential of the renewable energy in Indonesia, actually of the solar energy in Indonesia, is in between around 200,000 megawatt. Meanwhile, the utilization of the solar energy right now in Indonesia is only around 150 megawatt, or it's only 0.08% of its potential. It was a small number have been implemented in Indonesia. And on the other hand, looking at the potential of solar energy, is it already efficient enough to implement it? We know that right now the solar energy system, which is that it still depend of the weather, it still depend of the sunlight, the situation of the weather, which is that when it night, when it doesn't get the sunlight, so it's gonna get the source of the energy of the solar energy. And but can you imagine if we have the solar cell, which is that doesn't it's not depend of the weather situation, which is doesn't matter is it night, doesn't matter is it rainy, so it can have the long term the operational system of the solar cell, so it can operate until night, until in the morning, which doesn't matter of the weather situation. So we can make can have the long-term operational of the photovoltaic system, which is that gonna be more suitable in the solar energy future. Therefore, we are from Sriwijaya University. We propose the boost power conversion efficiency in dye sensitized solar cell using a thermoelectric generator integrated with Triboelectric Nanogenerator with sustainable under climate condition. Which is that from this innovation, we are using to approach, like the first one is a direct approach from secondary data, and the second one, the innovation-based approach that describe these innovation tools and advantages. Okay, and from this innovation, which is that consists of some of main material, like the first one, we are using the Dye Sensitized Solar Cell, the Triboelectric Nanogenerator, which is integrated with the Thermoelectric Generator, which is because it can be used as a promising power source for the next generation of a smart electronic. And then from that main material, we are using the PEDOT PSS to make it the mutual electrode system. It can be used by TENG and Dssc, so it's not run for the the individual system. And then in addition, we are using it's named the PDMS. So we can integrate it of the Triboelectric Nanogenerator and Dye Sensitized Solar Cell. And also from that, the efficiency of our main material, such as the Triboelectric Nanogenerator, Thermoelectric Generator, and Dye Sensitized Solar Cell, it can bring until 30% of the efficiency of the operational of this photovoltaic integration, as you can see in right here about the efficiency from the TENG, the Dssc, and TEG. And how does it work? Okay, the first one is when the sunlight is in contact with the solar panels, the sunlight will pass through the triboelectric layer, so that solar energy it can absorb by the Dssc, and then the Dssc is where the sunlight will accumulate heat so that it can reduce the performance of the Dssc. This heat source will be channeled to the cooling medium so as the create heat transfer that utilize the tank and to generate and the electric current. And then when it's the rainy season, the solar panel will have difficult getting sunlight, right? In this condition, the Triboelectric Nanogenerator, it works by converting the mechanical energy of raindrops to electric current. And then the last one is the Thermoelectric Generator. This design aims to maximize the use of solar energy while minimizing heat loss that occurs in solar panels. And we have some of several advantages, as you can see in here. And then from this innovation of the mechanism, this innovation, the impact of the three pillars, we have three impact of the three pillars of on society development, economy development, and the environment. And the last one, we expect the one of the our output is a domino effect of the sustainable development goals to be reached until 2050.
Talking about the stakeholders, in this process of implementing this innovation, it is necessary to have the role of several stakeholders. And then this innovation will work with several stakeholders from energy community, government, BUMN, media, JICA academics, practitioners, and private companies. Next. Talking about TOS and PESEL analysis, the following are various TOS and PESEL analysis as internal and external to see the various advantages and opportunities available to innovation to develop, to see what threats need to be available, to be anticipated, or minimized so that increasingly become a sustainable business. Next. As you can see, this is the timeline of our implementation that consists of concept analysis stage, and then infrastructure design stage, and then infrastructure development stage, and then test stage, and the last one in implementation and replication stage. Next. About risk and mitigation, I know that every solution I offer has risk and I must carry out a mitigation plan. And there are 5 main risks that I have analyzed and access to each of risks for mitigation to find and develop solution that can run smoothly. And of course, there will be an impact flow that will occur those of main impact flow. Next. And therefore, about the conclusion, towards the conclusions of some of the existing problems related to climate change and the conditions of the solar panels, lots of lost energy and still expensive one. This handling also through surveillance system that is still considered conventional. And of course, there is a solution that I offer with a profitable quantitative analysis. And of course, I carry out risk analysis and mitigation to be able to the perfect solution that will be implemented. So that the impact I expect is a domino effect to be able to reach until 2013. It's all from us from Sriwijaya University and for Indonesia and for a better life. Thank you.